Hello everyone. In this video, we're going to be solving a geometry puzzle. If you like this video, please comment, like, and subscribe, and hit the bell button for notifications. And let's get started. Two vertices of a square are on a unit circle, and one of the sides of the square is tangent to the circle. So we have this large square that is tangent to the circle at a point like this. Another square, which is the smaller one, is inscribed in the region shown. Find the area of that square. So we're going to be finding this area, which means we're going to find the side length first of that shaded square. Cool. So what do you do first if you are faced with a geometry puzzle? Okay, you make connections. That is right. So let's start by making some connections. So I'm going to start here. I'm going to extend that line like that. Cool. And then I will be connecting the center to one of the vertices of the square because I'm going to use the Pythagorean theorem. Okay, if the side length of the square, now I do know that the radius of the circle is 1, right? So it's a unit circle, which means these are all 1. Great, because this is the center of my square, right? Okay, so suppose the side length for the square is x, all right? So I have a square here. I don't know the side length yet, but guess what? In order to be able to find the side length for the smaller square, I have to find the side length for the larger square first. It's not been asked for, but I need to find it first. Or it will be easier, whatever. So, what am I going to do? Well, we made the connection, so we should be able to find something from here. Well, here we go. This is also a side length, so that's x. Since you take out the 1 here, this piece should be x minus 1. Great. And from symmetry, this should be a midpoint, right, for this side. Therefore, this is going to be half of x, which is x over 2, right? Great. So now I can use the Pythagorean theorem. Yeah, good news. So let's go ahead and write down the Pythagorean theorem in that right triangle. And if you haven't seen that right triangle yet, let me go ahead and shade it for you. I'm talking about this right triangle here. Okay, so we're going to go ahead and use the Pythagorean theorem there. And it's going to look like this. X minus 1 quantity squared plus x over 2 squared, which is x squared over 4, is equal to 1 squared, which is 1. Awesome. Let's go ahead and expand this and solve this equation. I get x squared minus 2x plus 1 plus x squared over 4 is equal to 1. Obviously, the 1 cancels out, leaving us with an easier quadratic. This is very easy to solve because it's factorable. Okay, because it's missing the constant term. If you multiply everything by 4, it would probably be a good idea because that would simplify the process. And we'll get rid of all the fractions. Obviously, on the right-hand side, you have a 0, so it doesn't really matter. 0 is awesome. Okay, great. So now we get 5x squared minus 8x is equal to 0. From here, I can take out x. This is why this quadratic is awesome, because it's factorable. And I get 2 factors. Obviously, x equals 0 is not valid because you don't want your side length to be 0. That would just shrink it to a point, right? So we're going to go with this, or our only option. And from there, we get x is equal to 8 over 5. So basically, the side length for the larger square is 8/5. And doesn't that kind of make sense? It's about 1.6. Did I say about? Okay, whatever. This is 1.6 and the radius is 1. So half of that will be 0.8. Yeah, it kind of makes sense because it's less than 1. Okay, cool. But how do I find the side length for the smaller square? Great. Awesome. So let's go ahead and clean up here, and then we'll go and find the side length for the smaller square. That's going to be our next thing to do. But before that, let's go ahead and write down what x is. X is equal to 8 over 5. So let's go ahead and take note of that. X is equal to, oops, that wasn't a really nice area. It's hard to see, right? X is equal to 8 over 5. And remember, x is the side length for the larger square. Great. So let's go ahead and clean this up, right? You're going to see everything. I can keep x probably, right? Because that's going to be used, well, somewhat, right? Okay, cool. Now, what am I going to do? Well, I'll be making more connections, but this time, I'm going to be focusing on the smaller square. And obviously, we need to do more cleaning. So awesome. So now, what am I going to do? Well, I'm going to make more connections, right? So how do I make more connections? Focusing on the smaller square. Well, I'm going to start at the center again because center is important. You start here, go all the way down, right? So now notice that you're not touching the circle. You're gonna stop, and it's kind of hard to see because this figure is not necessarily scale. Well, I should say you have to zoom in more to see that space. Obviously, there is some space between the side of the square and the circle arc, right? The circular arc, there is some space there. Okay, cool. Now, we don't know the side length for this, so let's go ahead and call that A. That's what we're trying to find, right? Or the area. So this would be from symmetry, half of A, right? Because that's a midpoint. So this will be like A over 2. But I still need the Pythagorean theorem, right? So I do need a right triangle here. How am I going to use that? Well, I'm going to make more connections. But this point, now even though this point is on the smaller square but not on the circle, this point will be on the circle. Two of the vertices are on the circle, right? Okay, cool. So that might help me make some good connections here. Let me erase this, like I don't want that in the way. So let's go ahead and make a connection here. I'm going to go ahead and connect the center to one of the vertices of the smaller square. Now, how is that going to help me? Well, that's going to give you a right triangle, wouldn't it? Yes. What about the lengths? Well, here's one thing that we're going to use here. We found that x is equal to 8 over 5, right? So how do we use that? Well, the whole thing is 8 over 5. But remember, from this point to that point, that's the radius, right? So that's 1. If you subtract 1 from 8 over 5, which is the whole thing, right? Then you'll get 3 over 5. So this is 3 over 5. Great. So what about this piece? Well, that's A, the same as the side length of the smaller square. Cool. And then the height of this triangle here is going to be half of A, which is A over 2. Okay? And then we got our right triangle. But what about the hypotenuse? Well, the hypotenuse is the radius of the unit circle. Yay, awesome. So that's 1, right? Great. So basically, that's how our setup is going to work. We're going to be using this tiny right triangle to find A, and then we'll go ahead and find the area. All right, cool. Let's proceed with a nice color. Which one is nicer? I think this is good. Okay, cool. So I'm going to write down my equation here. I have 3 over 5 plus A. And you're going to get a really nice expression from here, by the way, squared. And then if you square half of A, that's going to be A squared over 4. And again, the radius is 1, so it's just going to be 1. Cool, right. So let's go ahead and expand this, simplify it, and then find A from there, and then we'll find the area. Cool. So this is going to be 9 over 25. This is going to be 6 over 5A, remember the 2AB rule, plus A squared over 4 is equal to 1. Now notice that my denominators are 4, 5, and 25. So if I multiply both sides, maybe, you know what, I'm going to do the following. I'm going to add these first. Guess what? I mean, these are easy to add, these two things. And then I'll keep this guy like that. Okay, and then subtract the 9 over 25 from the 1, which is 25 over 25. That's going to leave me with 16 over 25. Great. Now, in this expression, notice that we can multiply both sides by 25 times 4, which is 100, right? And that's going to simplify things greatly. So if I go ahead and multiply everything by 100, like this, let's go ahead and do that. Multiply by 100. And multiply by 100. Of course, you can cross cancel here. 25 goes into 100 4 times, so I'm going to get 64 on the right-hand side. And don't forget to cross cancel as you go. 4 goes into 100. 25 times 5 is 125. A squared. 5 goes into 120 times. 6 times 20 equals 120, right? A. And that equals 64. Great. Now, what am I going to do here? I'm going to put everything on the same side. 125A squared plus 120A minus 64 is equal to 0. And obviously, from here, you get a positive and a negative solution. Why? Using Vieta's formulas, the product is negative, and we're going to discard the negative solution. So we're going to go with the positive. But how do you solve this? Is this factorable? I don't know. I mean, you can try to factor it, but that might take a while to do, even if you use the X method. But I will use the quadratic formula. Okay, let's go ahead and use it. The numbers are large, but we should be able to simplify this. Great. So now I should be getting something like negative b, okay, plus minus the square root of b squared, which is 120 squared, minus 4 times a times c. And since c is negative, this is going to turn into a positive, and we'll get a nice product, right? Well, not so nice, but kind of large numbers. Okay, cool. Now, there must be a way to simplify this, right? Don't you think? I mean, we're dealing with very large numbers, right? Well, 4 times 125 is 500. So we're going to be doing the following. We're going to find a common factor, obviously. Well, do you think the right-hand side is divisible by 120? At least I can take out a 120. That would really simplify things because I would probably deal with smaller numbers that way. 120, we definitely have a 4, but do we have a 30, right? Well, if you multiply 125 by 4, you get 500, which is not divisible by 30. So the problem here is we don't have a 3, right? None of these numbers will contain a 3 in them, so we don't really have a nice common factor. I mean, at least a 3 is not the common factor. We know that. But we do have the 2s and the 5s. So what I can do is I can go ahead and break this down into prime factors and then look for a common factor that way. Because I don't want to square 120, and that's going to be a very large number. So 120 squared, how can it be factored? 120 is 3 times 4 times 10. Then we're doing a little number theory here. 3 times 2 squared times 2 times 5. That should give me 2 to the third times 3 times 5. Then I'm going to square this expression. So that's going to give me 2 to the 6, 3 squared, and 5 squared. That's one of my factors. The other factors are going to be 2 squared. I'll get a 5 cubed. And that's a 2 to the 6. So it's going to make it 2 to the 8th. Great. So now we're looking at for a common factor of these two expressions, which shouldn't be too hard to find. And that seems to be 2 to the 6 times 5 squared. Beautiful. Why is it beautiful? Because that's a perfect square. Nice. So I can take it out. Beautiful. Now, when I do that, let's see what happens. Negative 120 is going to stay. And I'd like to factor 2 to the 6 times 5 squared. By the way, what is that equal to? It's 64 times 25. Wow, that's amazing. What is 64 times 25? Well, it's 1,600. How did I know that so quickly? Because there's a shortcut for that. But anyways, so we can take out that number, which is cool. So when I do take that out, what am I left with? Well, when you take out a 2, 6, and 5 squared, you're only left with 9. By the way, 16 times 9 is 144. I should have known that, right? Okay, anyways. Plus, when you're pulling out 2 to the 6, 5 squared from here, you end up with 2 squared times 5, which is 20, right? Wow, that's also interesting. Okay, well, 500 times 64, what do you expect, right? That's what it is. Wow, that's really cool. You know why? Because the number that's left over is actually pretty small. So it's manageable, fairly manageable. Great. So I'm going to leave these calculations here. I'm not going to erase them, but let's go ahead and simplify this guy. 1600 is going to come out as 40, right? And again, I said that I'm going to discard the negative solution, so I get a 40 outside. Inside, I have a 29, which is prime, so leave it there. It's cool. And everything divided by 250. Cool. Let's simplify this a little bit. I can definitely divide by 10, right? And if I do, what am I getting? Well, if I divide by 10, I should be getting 4 root 29 minus 120 divided by 25. Guess what? This is just a. We're supposed to find the area of the square, so we're going to square this. But before we square, I want to tell you something. There's something that will make this calculation a little easier, that factor out the numerator. Because even though you can find a common factor to simplify this more, you can still take out a 4 in the numerator, right? That would be helpful, I think. Square root of 29 minus 30, because it's a lot easier to square this expression than the other expression. Okay, cool. Now, I'm going to find the area of the smaller square, which is the tiny one, and that is equal to this guy squared here, 4 times the square root of 29 minus 30 divided by 25. And then I'm going to go ahead and square this. And when I square that, I should be getting something like this. 16 in the top. And then this expression squared is going to be the square root of 29 is square root of 29 squared is 29. 29 plus 30 squared, which is basically 929, right? Minus 60 square root of 29. And then that'll be divided by 25 squared, which is 625. Okay? So if you don't like that to be, cut off like that, we can go ahead and move it here for your convenience so it looks better. And that basically brings us to the end of this video. I'd like to say thank you for watching. Don't forget to comment and like and subscribe. I'll see you in the next video and take care. Bye-bye.